Chapter one. Chapter one is sampling and data. It's kind of like our introduction to all of our statistics probability part. All right, and you're going to see that chapter one and chapter two are kind of separated in its own and talks about visuals and how to organize the data. And then once we move out of chapter two, then chapter three starts more of the probability part of it. So we're going to start with chapter one, section one. Starts with definitions. You have statistics probability and key terms, as you can read. So here are a few definitions. First, I'm just going to read a couple, then I'm going to kind of go into them a little bit more. So I know you guys can read. Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. And then the way they separate is probability is the likelihood of something happening. So stats is basically organizing all of our things and drawing conclusions. And probability is saying that what's the likelihood of this happening, this event occurring, or this just something happening. Then we're going to look at the two different types of statistics first. So we're going to look at descriptive and inferential. And the really big difference is descriptive is using things that were collected as data, right, during the process. So there are true facts, live facts. There are things that were collected and known to be now true, whether they were collected during the study or maybe outside the study. Inferential statistics are using predictions, basically. Predictions based off of maybe statistics that we've drawn in. So maybe data that you've collected, and then now you're going to use inferential statistics to make predictions about what's coming up ahead, or maybe what has happened because of this. But the main thing is this key right here, as it says that it is making predictions. So there's a quick little couple examples. I want you just to read these, and then I want you to pause this, and you try to figure out which one is descriptive and which one is inferential. So go ahead and pause this now, and then when you come back, I'll explain the answers. So the first one says the average price of a 30-second Super Bowl, or a 30-second ad for the Super Bowl this year was $5.6 million. All right. So when you read this, you have to ask yourself the question: is this based on data that we have, or is this based on that we're predicting this is going to happen because of the data? And in this case, this is the main thing is that we're talking about the average. So here's our key feature here, the average. So what we're going to say is this is talking about the actual data that we have collected. In this case is descriptive. And that's mostly because it is average. Uses the keyword average. All right, the next one says a medical report stated that taking statins in order and is proven to lower heart rate or heart attacks, but some people are at a slightly higher risk of developing diabetes when taking statins. So you have to look at this and you say, okay, well, is this using descriptive data where we have now these hard evidence, or are we taking these and using these as predictions? All right. So in this case, there is no hard evidence that we're just basing our facts on, right? What it says is right here, it says that some people are at a slightly higher risk of developing diabetes when taking statins. But here, it also says that it's proven to lower heart attacks, okay? All of these are based off the stats, the data, but then now we're making predictions along the way. So in this case, this one is inferential because we're using predictions. Oops, sorry. All right, so there's 6 terms here, and we're going to use all 6 in the next slide. And you're going to have to label these, so you might want to flip back and forth to these as we go to the next slide here. So these 6 key terms are basically what the scope of what our data is taken, basically what's happening. So we have our population, which is everything that we're being studied. A sample is a piece of that population. The parameter is the whole population, but we're going to measure it by some kind of statistic. And then a statistic represents a property of the sample, and we'll talk about more. You'll see that here in the next example. And then a variable is basically a measurement, so we can say like, well, it's easy. It's a variable, all right? And you'll see here. And then the last one is the data. They are the actual values, the measurements that you're taking. All right, so our example, it says determine what key terms refer to in the following study. A study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. So there are 7 different things, but we're only gonna, we only had 6. So if you remember, we have 6 here. So there's gonna be one that we don't use. So what I'd like you to do is go ahead and pause the video. And then I want you to see if you can, just based off the definitions that I just gave you, see if you can start tying some of these together. And then I want you to come back, and then I will go over them. So go ahead and pause it now. I'm going to pause too, so a little black screen comes up, and then you can take your time. So first, I want to go over exactly the order we went through. We went through population was the very first one. So let's find the population. It consists of everything. So it says a study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. And if you read this, you can see there are 2 possibles. There's either A, because it says all students who attended the college last year, or it's F, all students who graduated from the college last year. So there's a big difference, and the difference is this right here, who attended and then who graduated. So look back at our original, the study. A study was conducted at a local college to analyze the average cumulative GPA, so that was what's being computed, of students who graduated last year. So we don't necessarily care about who all attended, because we're only looking at the people who graduated. So in our case, the population is not A, the population is our letter F. I'm going to try to squeeze these words in here. So this is population. All right. Okay, so next one is our sample. Our sample is, well, what are we sampling here? And so you should have selected letter D. We're selecting a group of students who graduated from the call last year, and they're randomly selected. So this one is our sample. Letter D. The next one is our parameter. Our parameter, if you saw it right, would be letter E. It says the average cumulative GPA of students who graduated from college last year. Remember, our parameter is a numerical characteristic of the whole population that can be measured by one statistic. Okay, so what are we measuring here? We are measuring the GPA, and again, it's represented by numeric values. So letter E is our parameter. The next thing was our statistic, right? So this is talking about, again, the definition says, is a number that represents a property of the sample. In this case, our statistic is letter G, the average cumulative GPA of students in the study who graduated from the college last year. So here's our statistic here. All right, so moving on, next we're going to identify our variable. Now, you see that we only have a few options left, right? So we've eliminated everything but A, B, and C. And really, we kind of already thought about A, and A didn't fit because our better population was F. So the 2 that we really have here are B and C. You have to think about, okay, well, variable is a measurement that can be determined for each member of the population, and data are values. So you should identify, the easiest one I always identify as is I am able to identify the data. So letter C is our data because those are the actual values, our numerical values that represent this. And then our variable, the cumulative GPA of one student who graduated from the college last year. So this would be our variable. All right, so that's all of what we're going to cover in section 1 in our text. All right, so I'm going to move on to our next section. The next section is data, sampling, and variation in data and sampling. So the first thing I want to look at are a couple types of variables. So we have qualitative variables and quantitative variables. So qualitative, they can be put into distinct categories or some kind of characteristic. Quantitative are numerical and can be ordered or ranked. And you're going to see that we're going to talk about these more. And quantitative can be classified into 2 groups, discrete and continuous. So before we move into what's qualitative and what's quantitative, because we're going to get to that, what I'd like to first is identify what is discrete and what is continuous. Discrete are values that can just be counted. So numbers like 1, 2, 3, 4, 5. Okay. So you could say like, how many eyes you have? You have 1, you have 2. There's no continuous built of the eyes, right? You don't have 1.5. You don't have 1 1/4. You either have 1. You either have 0, 1, or 2 is how it works, right? So then you have continuous. Continuous variables can assume an infinite number of values, so anything in between two specific values. So that would be where you say like, well, you can't say that number of eyes are continuous because either you have 0, 1, or 2 eyeballs, right? You don't have 1.5 eyeballs. You don't have 0.75 eyeballs. So they're obtained by measuring things. They include fractions and decimals. So let's identify. So one of these is continuous, one of them is discrete. Go ahead, pause this video here, and then you identify which one is continuous and which one is discrete. So I'm going to start with trying to find my discrete, because I know one's discrete, one's continuous. So discrete, I'm going to read the first one. It says the number of hours during a week that children ages 12 to 15 report that they watch television. All right, so I'm talking about hours. And when you talk about hours, you could be talking about 0 hours or 1 hour or 2 hours or 3 hours and so forth. The next one is the number of touchdowns a quarterback scored each year in his college football career. Okay, we talk about touchdowns. Hey, he threw 0 touchdowns, or he threw 1 touchdown, or 2 touchdowns, or 3, or 10, or 20, right? So you think about which one cannot be reported as decimals or fractions. In this case, it's touchdowns. You've never seen a stat that says a quarterback threw 2.5 touchdowns, right? That doesn't happen. All right, so our first one here, discrete, our discrete here is the number of touchdowns, which makes the number of hours during a week that children ages 12 to 15 report they watch television is continuous. And the reason why that is continuous is because it can be stopped at any time. So, for instance, I have children, and my children do not watch just 0 hours of television per week or just 1 hour. They could watch 30 minutes, which is half an hour, right? Or maybe 45 minutes, which is 3/4 of an hour. And that's maybe all they watch in a week. So that's why this is continuous and not just discrete. All right, so now what I like to do is talk about quantitative and qualitative. So let's remember, so qualitative, we talked about first, is basically things you can put into a category. And it says right here, indicate whether their quantitative data are continuous or discrete. So when you talk about quantitative, you have discrete or continuous or discrete. The hint, data that are discrete often start with the words the number of. Just a little hint, all right? It's not the only way, but often it starts like that. So I want you to go through and label them as quantitative or qualitative. If it is quantitative, identify either as discrete or continuous as well. So I'm going to pause this here. You take a minute to try to write what you think, and then come back and all the answers will actually be here. So here we go. Check your work. See if you got it right. So go ahead and just take a minute, go ahead and pause it, check your work, and then start it again. All right, so you should have paused this, checked it, now I'm going to talk about it. So let's just go down the road. Let's look for qualitative first. So if you look at our qualitative ones, our qualitative are letters B and letters E. Okay, those were our 2 qualitative ones. Again, the type of car you drive, so it's categorical. Do you drive a truck? Do you drive a Jeep? Do you drive a car? Do you drive, we could even say convertible. Do you drive a motorcycle, right? Do you walk? Do you drive a bike, right? So the type of car you drive. Then letter E says the type of calculator you use. So what type of calculator are you using? Are you using your phone? Are you using your iPad? Are you using a tablet? Are you using Desmos? Are you using an actual calculator where it's a TI-30 or a TI-84 or a TI-86 or a TI Inspire? Right, these are all the categories you would put it in. You cannot measure it based off actual values. Okay, now we're going to look at quantitative, and I want to look at discrete first. So everywhere it says discrete here, we're going to look at those to try to distinguish those. So the first one is letter A, and it says the number of pairs of shoes you own. I know you might say, well, what if I have like only one shoe and the other shoe is gone for the pair? Well, I mean, I don't know about you, but that hasn't happened to me yet. I usually can keep track of both shoes in the pair. So you either have a pair of shoes or you don't, because even if you only have one shoe to the pair, you don't have a pair anymore. You just have a shoe, so it falls out of the category, right? So it is discrete. You have one pair of shoes, you have two pairs of shoes, you have three pairs of shoes, and so forth. Then the number of classes you take per school year, that is definitely discrete. You're either taking no classes, maybe you're taking the semester off, you're taking one class, taking easy light load, or two classes that take an easy light load. And all of a sudden, maybe you're working less hours and you're trying to put in more work at the school. You can take three classes, four classes, and so forth. So those are discrete counting numbers. The last one is the number of correct answers on a quiz. There is no such thing as 1.5 correct answers on a quiz, right? Either it's right or it's not right. Now, it might be partially correct, but there are only a certain number of correct answers on a quiz. The last one here is our quantitative continuous. So here's continuous here. There's three of them. So letter C says the distance from your home to the nearest grocery store. It is continuous because as you are walking home, you are getting closer. So it is not just, maybe it's a 3-mile walk to the grocery store. You take a few steps, you go for a little bit. Now you're 2 3/4 mile, to the grocery store. So you're getting closer and closer and closer. Letter F says the weights of sumo wrestlers. Well, they are continuous because, it could be the weights of anyone. Just sumo wrestlers was the example. But if you take the weight of anyone, it's going to be continuous because weight fluctuates, right? It fluctuates even throughout the day. It fluctuates through even at the morning. And then H is IQ scores, and they are also continuous because they also fluctuate. Now you might say, well, discrete, it could be IQ score. My IQ score is this number. Maybe at that specific time, but maybe if you take it 10 minutes later, your IQ score might change. It could be worse, it could be better, right? So the scores are continuously evolving. Our next example says a statistics professor collects information about the classification of her students as freshmen, sophomores, juniors, or seniors. The data she collects are summarized in the pie chart. What type of data does this graph show? Remember, is this categorical or is it numerical? And then if it's numerical, is it discrete or continuous? All right, that's what you should be looking at. So in this case, there are no numbers. It's talking about freshman, sophomore, junior, and senior, which means that this is completely categorical. Therefore, it is qualitative because it is categorical. And you don't have to put why. You don't have to put that it's categorical. I just keep saying that because I feel like that helps even me think, is this quantitative or qualitative? Is this numerical or categorical? All right, the next one we're going to move on to is sampling. So sampling is used in a whole bunch of different ways, mostly through surveys, right? Maybe sometimes they do it through a telephone anymore, but mostly it's mailed or emailed, right? That's probably the most common way. Or if you're end of some kind of service that's been provided, maybe that's through telephone. If you've ever called like your cable provider and says, please stay on the line for a quick survey, right? That would be how they collect data there. And to obtain samples, there's 4 different ways that we're really going to look at. And that's simple random sampling, systematic sampling, stratified sampling, and cluster sampling. All right, those are the 4 different ways. And I'm going to give you actually 2 other ones, but these are the 4 different types of sampling methods that are used very, very common. So I know you can read, so I'm going to go through each one. Simple random sampling is just saying that everyone has an equal chance of being selected. All members in the population. And sometimes it's assigning random numbers. So if there's 500 people, everyone gets a number 1 through 500, and then you just select them, maybe drawing out of a hat, like the bingo balls, stuff like that. Systematic sampling is saying, okay, every maybe 3rd person or every 5th person that's in line, we're going to select that person. Stratified sampling is basically saying we're going to divide everything into population. This big population, let's say there's 1,000 people. But now I know the example I say freshmen, sophomores, etc. So let's say we take the college. And we take the college, we take all the students, which is the whole population, and we're going to divide into 4 subgroups. Freshman, sophomore, junior, senior. We're not going to talk about graduate school. We're just talking about the undergrad stuff. All right, so freshman, sophomore, juniors, and seniors. Then everyone in that subgroup is going to be selected at random. So not everyone is selected, but now we're going to take that maybe freshman class, and we're going to use some of those freshmen. Now, maybe we do simple random, where everyone just has a number, and we just out of a hat every 10th person of that freshman group. Or maybe we use systematic sampling, where now it's every 4th person in that freshman class is being used for an example, for a sample. Now, cluster sampling and stratified samples are two different ways, or two different ones that that relate very well. Cluster sampling is we're going to take everyone, divide them into sections, into subgroups. Same thing as stratified, but this time, everyone in that subgroup are going to be used. Okay, all members, and here's the key word, all members in the cluster are being used. Okay, where stratified are just random in the cluster. And then the last two are ones that are also common, but we're not going to talk about them too heavily. And that is convenience, when it's just easy, right? So maybe you're standing outside of a grocery store, maybe it's your job and you're working at the grocery store, and you just ask, like, how was the service today? Would you rate it as a, between 0 and 10, 10 being the best, what would you rate your experience today? You give them a number and say, okay, thank you. That's convenience, because you have to walk out the door of the store, right? Volunteer sampling is things where you get an email and they say, would you like to volunteer for this survey? Sure. All right, it's volunteered. That could also be a paid volunteer, right? There's sometimes they'll say, we'll give you $1 if you take this survey. A lot of people do it for $1. All right, but these four right here at the very beginning, these are the most common. Those are what I'm going to focus on the next slide as well. So which sampling method is being used? So what I'd like you to do is go ahead and read through all of these. Go ahead and pause the video here shortly. Read through them, and then it's either going to be one of those first four, either simple random, systematic, stratified, or cluster. All right, so go ahead and pause the video now. All right, so I'm going to go ahead and work it with you. So the first one says that out of 25 high schools, so what they've done is in Stanislaus County, they have put them in populations and subgroups. The whole population of Stanislaus County, and they're subgrouping them into high schools. And a researcher selects one and collects records of the graduation rate. So that means what they've done is they've taken one of those subgroups and selected all of those graduates, or all of the records of the graduation rate. So think about it, it's all of. So we are now in cluster sampling. The next one says the researcher divides a group of students according to gender, major, and GPA. Then she randomly selects 4 students from each subgroup to take the survey. So they're not selecting the whole subgroup, but only certain people from a subgroup. So this is where they get confusing. It's not cluster, this is stratified. Oh, sorry about that. Next, Twitter users are all assigned numbers. Then a sample of these people are selected using random numbers. This goes back to our very first thing. It's simple random. So simple random. And you'll hear it too. It'll be also classified as just random sampling, not just simple random. All right, but our text and uncommon way is also simple random. The last one is every 8th bottle of Kirkland purified drinking water and the amount of water that was in the bottle was measured. So every 8th bottle. So now we are systematic. Okay, one more thing to cover in this section are errors. There are a couple of things that come up with errors. There's something called a sampling error. So the results of the sample and the results of the population, there's a difference between the two. Okay, and then the non-sampling error occurs when the data is obtained incorrectly or the sample is biased. So basically what it's saying is there's some kind of error inside of the collection. These are just things that happen. Not that you're going to be tested on this heavily. This is just something that I just want to make sure we talk about. All right, so moving to the next section. Section 3, the levels of measurement. This is going to be the last section we cover in this chapter. And there are a few definitions that we're going to fill out this chart. So the first one is a frequency. A frequency is the number of times something actually occurs or appears in the data. The relative frequency is the fraction of times an answer occurs. And we'll talk about that, right? So let's say, for instance, I have 40 students and I say, how many of you have a dog? And 10 out of 40 have a dog. So what's my relative frequency? My relative frequency would be 10 over 40. And then I would take and I would say, okay, well, that's my fraction. What's 10 out of 40? That's 0.25. This would be my relative frequency, which leads me into my cumulative relative frequency. It's the sum of all the relative frequencies of the previous relative frequencies. And you'll see that here in the table. So in our example, it says complete the given table using the data. 20 students were asked how many hours they work per day. Their responses in hours are, and then you can see. So what we're going to do is we're going to fill out this table. So first off, the data value. Data value are the actual pieces of data in our set. So if you look at what we have numbers in here. And if you look at all the different numbers, we have the numbers 2. So it shows up here. We have a 3, 4, 5, 6, and a 7. All right, so I'm just going to write all those down. So 2, 3, 4, 5, 6, and 7. I'm not saying how many times they appear yet. I'm just talking about the different types of values show up in our set. Now we're going to talk about how many times they show up. And here's one way of doing it. You don't have to do it this way, but a very common way of doing it is crossing it out as you go. So I'm going to go through and say, okay, 2, so there's 1, 2, 3. There's 3 2s, so here's 3. Now I'm going to go and find all my 3s. There are 1, 2, 3, 4, 5. So now I have 5 3s. Go with my 4s, and you get the picture. So I'm gonna pause this, and you come back, and they'll be done. You go ahead and do it yourself. All right, so these should be the frequencies that you have derived from what we have. So if you look at it, all of the numbers up here are all crossed out. Everything is crossed out. So I know I've taken care of all the other numbers. What's another way I can do it? Well, right here it says that 20 students were asked. So I know that there are 20 different pieces of data here. So I can either go and make sure, hey, there's 20. There should be, right? The other way, when you do this, make sure they're all accounted for. This should add up to 20. So 3 plus 5 is 8. 8 plus 3 is 11. 11 plus 6 is 17. 17 plus 2 is 19. And 19 plus 1 is 20. So I know that all 20 values are here. And that's important before we move to anything else. Now, relative frequency. Relative frequency, again, was defined as being the fraction of times an answer occurs. And this is where I want you to write the fraction and the decimal part of it. So if I look at the fraction part of it, change my color here to something different, and I look and I say, okay, well, my frequency is 3, but how many do I have? I have 20. So 3 over 20. When I put this into the calculator, it gives me 0.15. Next would be 5 out of 20. Put that into the calculator and I get 0.25. Now, once you go and finish this table and come back and they'll be here. Now, when you look at this, I didn't have to round at all, right? Nothing was rounded. 3 over 20 is 0.15, 5 over 20 is 0.25, and so forth. There was no rounding that I had to do. If you have to round, I want you to round to 4 decimal places, all right, when you have to come up with these decimals. Okay, now, hopefully you got the rest of these right. What we're going to do next is we're going to find the cumulative relative frequency. So let me explain this, because the cumulative relative frequency is adding the previous relative frequencies. So first is right here. There are no other frequencies. I'm just at 0.15. So in this box here, I'm just going to write 0.15. Now I'm going to show you the longer way, and I would like you to do this so that way I can follow your work. On the next row, I'm going to write down what I first have previously. So my very previous was 0.15. And now I'm going to add it to what's in that row, which is 0.25. When I add those together, I get 0.40. So up to that second row, my cumulative relative frequencies are 0.40. So 40% of my data are either a 2 or a 3. That's the way you would also read this. Now I keep going. So this 0.40 goes here, and I'm going to add it to this 0.15 plus 0.15. This gives me 0.55. So this says that 55% of my data come from either a 2, 3, or 4, 55%, which means that 45% are still to come. So I'm gonna pause this and you keep going, and then you're gonna know something. All right, so hopefully this is what you got, and you can notice that, put in a different color here, that this number always comes down. Maybe the yellow wasn't the most smooth way of doing this. Let's get the red here. This number comes down. That number comes down. Number comes down. Right? And where do these other values come from? These other values, let's see if I find a different color here. These values come from there. Those might look confusing now, but this is where they come from. Okay? And there is something at the end that I want to point out. It adds to 1. Why? Because it's saying that 100% of our data are the values 2, 3, 4, 5, 6, and 7. Now, I'm going to be very clear. If you do not have to round at all in the relative frequencies, like we didn't have to, then it will always come out, cumulative relative frequencies in the end will always be 1. If you had to round, it will not always come out to be 1. It may come out to be 0.995 or 1.002. Okay? It might be really close to 1. That doesn't mean you did anything wrong. That means you have a rounding error, and we take that into consideration. But if you did not round, you need to get 1 in the end.